So hello, everybody. Gonna introduce myself first. So I'm Julien Pauli. I've been programming in PHP for many years. Now I'm reviewing PHP internals code. So since about 3-4 years, I'm 5.5 release manager together with David. Perhaps you met him, maybe somewhere. I'm working in Paris, so I'm French. I apologize for my sometimes poor English. I like writing technical articles about PHP internals, and about open source software. So I'm working at BlaBlaCar in Paris. It's mostly a website talking about car sharing, through Europe. So we have many users. We have iPhone apps, Android application mobile, etc. And we run PHP 5.3 actually. Okay, so I'm trying through this talk to explain you how memory works in a Unix system. So I expect from you that you have a little bit C programming experience and sometimes machine code, hardware programming. We won't see any line of code. And I guess you are all PHP programmers, all right? And you have already experienced out of memory on your PHP programs, mainly in CLI scripts. And we try to understand why and how memory works in an operating system and in PHP, okay? So what is memory? We're going to talk about bytes, stack, heap in a process, okay? Not too deep. How to measure memory consumption of any process then in PHP, what tools we got for that. And we're going to try to understand how PHP manages memory in your script, okay? How it does to allocate and free memory. And then how to measure PHP memory into a script. So, memory from a hardware point of view, you all know this, I think, and I think you know memory from a software point of view as well. It's this, okay? So, in Linux, it will be mainly in Linux. I don't really know Windows internals, and other Unix, it may be different. In Linux, every process can consume the same amount of memory. We're talking about virtual memory. Okay, so I think you heard this word before. Virtual memory is just an image of the physical memory that your process can allocate. Okay, so when we talk about memory, mainly we talk about virtual memory. We cannot allocate physical memory from a user process. Okay, we have to code it into the kernel to allocate directly physical memory. So in Linux, every process has the illusion of being able to allocate the whole memory. And Linux will, by default, on the last version, the kernel will always answer, yes, here is the memory, okay? So you can have two processes with one machine with, say, 2 GB of memory. Those two processes can allocate both 2 GB of memory at the same time, but the kernel won't give 2 GB each because the machine and the physical hardware only get 1 times 2 GB. So it's gonna swap and it's gonna play with internal tables, okay? So in a process like PHP, you can allocate memory. You have two manners. You can allocate memory on something called the stack and something called the heap. I hope you know those terms. So while running, a process can allocate memory and then it can eat more and more memory. Talking about stack and heap, I recall you that the stack, it's just about function argument pushing. So when you call function that call function that call function, etc., you're gonna eat more and more memory from the stack. Okay, so the stack can exhaust memory as far as you call too many recursive functions in each other. Okay, that's not very common in a process. Well, it's easy to do, just a function that calls itself, and you're going to exhaust the stack size. But the most important is the heap memory. The heap memory, it's memory that the programmer can ask for at any time in the process life. Okay? And PHP is a process. So PHP can ask for more memory from the heap. Okay, using mainly dynamic allocation function like malloc or mmap under Linux. And the programmer, the C programmer, has to free this memory by hand. If it does not, then you have a memory leak. So how can we monitor memory from the stack and from the heap from a Linux point of view? Linux is very clever and gives us tools for that. Perhaps you know the proc file system under Linux. Okay, under the proc file system you have a virtual. It's a virtual file system, and under proc you have any PID, any process will create an entry in this proc file system. So if you have a process ID 28754, you can ask for its status, okay, just with cat, and you have information, and those informations, if you look on the web, you will have difficulties to know what it is about. You have to, mainly what I do is opening the kernel source and see what happens on there. And you have books that explain this. So mainly, you can see the virtual memory size. This is the size the process actually asked for. So this process is asking for a total of about 20 megabytes of virtual memory. Virtual, not physical. What is actually allocated in physical memory is what is called resident set size. So if you call top or tools like that under Linux, you will see mainly the virtual memory size. So you will have the illusion that your process is actually eating 20 megabytes in your physical memory. It's not the case. Okay? It can actually ask for 20 megabytes about, okay? But the kernel is actually allocating about 300 kilobytes in physical memory. And all this virtual memory size is divided with, stack and heap and other segments I won't talk about. So you have the stack here, and you have mainly, it's not really true, but you can consider this is a heap memory. Okay, so if you sum both, you should have the virtual memory size. You have other segments I won't talk about because it's a little bit complicated. Okay, so that's the first way to monitor memory under Linux. You can use, for example, the watch command on this, and then play with your process, and you can see the memory which is moving. So those numbers are real. Okay, the kernel gets you those numbers, so you can trust them, at least when you don't have kernel bugs. Some kernel have bugs, and they don't really, they display numbers that are not the real numbers, but on the latest version it's okay. In PHP, so PHP is a process like any other, we just saw, take care of functions like memory gate usage, you should all know, because memory gate usage will give you something you don't really know if it's heap memory, stack memory, if it's virtual memory or physical memory, okay? it's not very good to trust the numbers, at least when you don't know what they represent. That's what we're going to explain next. Okay? So the memory is mainly divided in segments, and you can ask for the memory map with the pmap command under Linux. Pass the X argument. It's better because if you don't, you won't have the resident set size. And on this process, I don't know what it is. It's a very small one because it's just bound with C library. This process, you can see all the memory mappings, okay? And what is called anonymous memory mappings mainly could represent the heap. So the heap is divided in several anonymous mappings. Take care of some of them because they are not really the heap. And the stack is over there. So this is just a mapping. You can do this on a PHP process, but you will have a very much more library linked, okay? Depends on how you compile it. So you can have even more details with the smaps entry, which will tell you more information if the memory is shared, because that's a very tricky thing. The kernel is very clever, trust it. And when you have two processes using the same libraries, you will have the illusion that the memory is used twice, and it's not the case because the kernel is very clever enough to map twice the memory, but on the same physical memory segment, okay, when it's read-only memory, mainly for code segments. So it's very clever about that. So I let you see this if you want and experiment on your own. And you have tools as well to monitor memory of a program, Volgrind, okay, which is a very nice tool. Volgrind will show you how much memory you are using in your process at any stage of, at any line of the C code in the process, okay? So you can do this for PHP. It's very interesting to see, for example, how the engine starts, how it starts allocating memory for opcode arrays, how the thing we call garbage collector allocates very much memory. I noticed this recently. And all you see, I recall you that all you see with Volgrind is a virtual memory, not physical memory, but it's not very far, but the kernel manages this for you. Okay, let's have a break and talk about PHP now, because it's what is interesting here. So PHP is just a process like all the others. So you can use the tricks I showed you before in PHP, okay? You have the getMyPID, which gives your own PID, and then you can, with PHP, you can watch its own memory consumption with the tools I showed you just a few slides before, okay? So you can grep resident set size from yourself, so you will have a very nice clue of how many physical memories are allocated by the process. Okay, so just start PHP and see it. It will be about 4 megabytes. For Java, you just switch the M to G, it will be 4 gigabytes. Something like that. It's very interesting to try. So try it by yourself. In PHP, so we use a stack, okay, when we call functions, and we use a heap. To use the heap, we don't call malloc directly. Malloc is a C function that gives memory from the heap. Okay, so you call malloc and you tell it, I would like 1 megabyte of memory, and it gives you a pointer on a buffer which is 1 megabyte large. It's about, okay? We don't use directly malloc in PHP. We use a layer that's been designed by the PHP community. mainly Sevsereski and Digetmans and other people, called Zend Memory Manager. You should have noticed this in the PHP information, perhaps, and if you wonder what it is, if it's enabled, and it will be, if it's enabled, it's telling you that PHP is using a great layer of C code over malloc, which is Zend Memory Manager. What is it about? Zend Memory Manager, it's just functions over malloc and free, okay? That gives memory to PHP, but memory of a well-known size. So the layer, Zend Memory Manager, has been designed to be very, very cool with the system, you know, and not calling malloc each time you require memory, because the most you call malloc, and the most you have a problem in time, because you're gonna have a heap fragmentation and things like that. Very hard to understand, but you can find things on the web about that. So Zend Memory Manager mainly allows caching of allocated blocks. It means that in libc, when you call malloc and then you free the buffer, so it's gone, okay? But if later you need the same size for the same buffer, you have to require another malloc call. In Zend Memory Manager, mainly we use zvol structures. I will show you what it is for PHP variables. And each time you allocate memory for zvol, when you free it, it's not freed back to libc and back to the kernel, okay? It's cached for the future calls. And when we will benchmark this on the next slides, I will show you that PHP is more speedy and it's better behavior when it uses Zend Memory Manager than when it's disabled. Okay. So here is a test script to benchmark Zend Memory Manager. Okay. So let's eat some memory. Okay, and this is a function you should know, range. It creates an array from, and it fills in the numbers from 1 to something very big. So it creates a very big array. Okay, so PHP will have to allocate many memory here. Okay, so let's show the heap usage just before, allocate memory, the heap usage after. Free this memory. This will stress as well because of arrays are hash tables, and I will talk to you about that later, how it works internally. And then call heap again, using Memory Manager and not using Memory Manager on PHP 5.4. So this is the trick to disable Zend Memory Manager on a process at runtime. You just pass an environment variable, use ZendAlloc, and then when you tell it use ZendAlloc equals 0, it will directly use malloc and free from the libc, and it short circuits, you know, you have no memory manager, no Zend Memory Manager anymore for this process. And what you can see using time, so benchmarking mainly this script we just saw, is that it's more efficient when you use Zend Memory Manager, actually, than when you don't use it. It's little, okay, because it's a little script. I let you imagine on a very, very heavy website with lots of classes and lots of requests, etc. It can really make a difference, okay? And about memory consumption, it's mainly the same, okay? Here there is a trick about memory not being freed by libc. This is an internal trick of libc, but we won't talk about it. So mainly you use a little bit more memory using Zend Memory Manager, okay, as you can see. But you are more efficient from a user point of view, from a kernel point of view. So in the total time, it's better using Zend Memory Manager. Let's use for grind, just one L, not two L's. So using Zend Memory Manager, we can see that the script we saw just before. Here it is, to recall you. So creating a very, very, very big array. Using Zend Memory Manager, it triggers about 22.22063 allocation using Memory Manager, and you have about 2 million allocation not using Zend Memory Manager. Okay, this is because Zend Memory Manager, when you ask for about say something like 4 bytes, Zend Memory Manager will allocate much, much more. So that's one malloc core, and then it will divide the memory into blocks. I will show you later. Okay, and then you have less malloc and free calls, and less malloc and free calls means more efficient, less time in kernel mode, and it's better for PHP. So you can see you allocate more memory, yes, it's about 10% more, okay, but you allocate and free memory less times, and it's very, very, very less times that not using Zend Memory Manager. Okay, one more test, bench.php, microbench. You can find this in the PHP source code, okay. It's mainly isset, empty, just one function call, 2 function calls, 3 function calls, and accessing strings like arrays just to test internal structure of the engine, and same results, okay. It's better using Zend Memory Manager than not using it. So it's more efficient, okay, but it has a cost. It's about 10% more memory and about 10% faster. It really depends on use case, because when you have a very, very big website with lots of objects, talking about frameworks nowadays, it's lots of malloc and free prevented with Memory Manager, so it's better using it. And what about PHP and PHP-LAN? You write a script, okay? If you enabled then Memory Manager, which is the default case, okay, you have access to 2 functions. You know, I think, memory get usage, memory get peak usage, okay, and the memory limit parameter, you all know. And finally, you have access to one more thing. This you should know. This is the message from Zend Memory Manager. The main goal of Zend Memory Manager is to control how many memory is used by your script. And when you reach a limit, it bails out, it shuts down, and it tells you fatal error. Okay, so if you disable Zend Memory Manager, you never meet this. But you will meet other problems if you are too hungry about memory. Okay, so those functions, memory get usage, memory get peak usage, I guess you know what they do. Should you know what the real parameter means? And that's what we're gonna show you now, because it's not very detailed in the documentation what is real and what is peak usage, even if we should know what peak is. Okay, so a quick word about Zend Memory Manager internals. Well, this, you can find this on the PHP wiki. I won't explain this because it is far, far, far more complex. Okay, but I will show you how Zend Memory Manager works. When you allocate memory, so you create a string, you create an array, you create an object, you just call a function or something like that, you need, say, 4, 5, or 10 bytes of memory, or say 100 bytes of memory. The Memory Manager will allocate segments, I told you a few minutes ago, and the segments are 256 kilobytes by default, size large. So when you create a string of 10 bytes, say, for example, PHP will allocate 256 kilobytes of memory, okay? And then it will divide the segments, okay? It will use the blocks in the segments to fit future needs. So when you free the memory and when you allocate more memory, it won't free it and it won't allocate more memory from the system. This is very clever. So you can see a segment as being divided in very, 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 very small blocks, okay? Say, for example, it's not the case, but say, for example, 1 byte per block. So the memory manager will use more and more memory. And when it reaches the segment size, the next call, we call for another segment. That's why you have something like that. Okay? So you're reaching the limit, and then when you just reach the limit, just say, I want 2 more bytes. Okay, let's allocate 256 kilobytes. I cannot do this. Here is the error message you all know. So it's divided into blocks, and it gives you all the blocks. And this is what memory gate usage and memory gate usage real is about. Memory gate usage will tell you how many bytes are busy, occupied in memory, okay, by PHP data. And get usage real, this is called the real parameter, will tell you how much memory the allocator has reclaimed from malloc and from your system, okay? So when you call memory gate usage, it tells you something like 100 kilobytes, okay? Let's say 100 kilobytes. It's not very true because the engine and the memory manager has allocated more than that, okay? You have to pass through to see how many bytes it has asked from the system, mainly malloc, okay? So don't be tricked by memory gate usage. And this is more complicated because we are talking about virtual memory and not physical memory, okay? So it's not really the same. And here is the memory limit. So on this example, we can see that I can I have something like this is allocated, okay? This has been allocated, but it's not used yet. So I can use this memory more, and PHP won't call for malloc, okay? And when you reach this limit, okay, say you just want 2 more bytes, it will allocate 1 whole segment, okay? So this will be blue, and the red will just reach this. And when you free, it will free the segment. It's not always the case. It depends on how it works. And you have a memory limit that you all know in PHP configuration file or through initset. You should know this. So memory limit, you know it. Memory gate usage, return the size of all allocated segments, and return the occupied size of all allocated segments. Okay, so don't be tricked. Be careful about that. And peak usage, it's just a marker. You know, you allocate. So it remembers how many bytes have been allocated, and then you free, but it still remembers the mark. And then you have memory get peak usage. It's the maximum memory that has been asked from the system by PHP. Okay, so it's interesting to understand all that. So how to reduce PHP memory consumption? In PHP land, you allocate variables, and variables are just store types, you know, PHP types, strings, integers, etc. And variables consume memory, okay? The memory is automatically freed by PHP when you don't use the variable anymore, okay? And here comes the challenge. When does PHP free memory? When don't you need a variable anymore? You should know this because when you pass variables to functions, to classes, and etc., it can be very hard to know when PHP is going to free your memory for you. So This is good to know. So internally, variables are just cval structures, okay? And the cval structure mainly got a Zend value inside. As you can see, Zend value can actually store any type of PHP. Okay, so if you use an integer in PHP, you will allocate a long value. Okay. If you use a float, you will have double. If you use a string, if you use an array, or if you use an object. Okay. Resources are something special I won't talk about. So all this is stored in a Zend value, which is stored in a cval. This is to sum up things. So if you remember your memory size of each type, this is Unix LP64, which you probably run on your servers. Long is 8 bytes, double as well. Pointer is all about stars. Okay, so all stars, any star, it's 8 bytes of memory. And a string, it's the size of the string plus 1 into the char star, and the length. Okay, because in PHP you have something we call binary strings. Binary strings, it means that your string can contain the \0 character. Okay, so we have to know the length of the string to parse it and not to get out of bound of the string. So what eats memory is not really the cval, it's what you store inside. For example, if you store 124A characters in $A, then you will consume the size of a cval, okay, plus the size of 124 megabytes, bytes, sorry, for your $A variable. So a huge string can consume, it's easy to compute for strings, it's just counting characters, at least when we don't talk about Unicode. Because Unicode is far more complex because you can have a character that can consume up to 4 or 8 bytes each, and that's why PHP 6 mainly has not been released, because it had a very, very huge memory consumption. We could not release it like it was. So when you have something like, I can see, this is from my experience, sometimes I read code and I can see file get contents from a very, very huge file. We'll allocate the memory for all the characters in the file get contents, okay? So be careful about that. Just use fopen, fget, then you allocate buffer and it frees the buffer when you don't need it. So just for the data you need. And file get contents is very, very huge. Complex array or object as well. And resources, it's something special. I won't talk. So what you want to avoid is PHP duplicate the cval. So now I show you how PHP manages the types for you. So when you say, for example, you have a string and then you put it in another variable, PHP won't duplicate the memory. Okay, it's very, very cool for that. It uses something called ref count. You should have heard about this before, ref count. If I go back just a few slides, this is in the cval. Up, it is. Okay, ref count and is ref, which means has it been assigned by reference or not. Don't use references. This is how I show you. It's very, very bad. So what you want is PHP free your memory as soon as possible, and PHP not duplicate your memory. Okay, so you have to understand how variables works. When you create a string, for example, this is simple example, foo, and you allocate to A, you allocate memory for foo. This is a memory. This is a cval. Okay, size of the cval plus 3 characters. Well, you have n character, but plus 3 character. And when you copy it to B, okay, actually PHP will not copy the memory. Okay, it will just link the B variable to the same symbol, and the ref count represents how many symbols, how many PHP variables are pointing to this memory container in memory. This is called ref count. So if we use something more complex, you can see that PHP is very kind about your memory. Okay, when you have B equals A, it's okay. When you change the value of A, as you can see, allocating an integer, 17 here, then B is still pointing to foo, okay, and the ref count is decremented by 1 because there is just one variable left on this structure, okay? And when the ref count reaches 0, PHP will free your memory, okay? This is what happens here. And you can use unset to decrease the ref count. Unset is not free, okay? Unset just unlinks a variable from a container and decreases the ref count by 1, assuming you're not using references. If you use references, all the behavior is changed, okay? You should know references because I guess you have already used references, so you should guess what's happening in PHP, so just don't use them. So you can see, because often when you use references, it won't do what you think it's gonna happen, and often it does the opposite. So it forces the engine to duplicate your variable when you pass it to a function because you get a reference, and the function doesn't take the parameter by reference. So if the function is going to change the variable, if it's a reference, PHP has to duplicate it, calling your function and freeing the duplicate when you use references. So it's not very, very nice. It's bad behavior. So PHP is very smart about your memory. Don't use references to try to hint PHP, hey, you're going to duplicate my variable. Here is a reference so that you won't duplicate it. It's often the adverse effect. Okay, it's the opposite which happens, so be kind about that. Know your ref count. I know it's not very, very easy to keep track of how many variables are pointing to there. So that I know this is a very big variable. It's a big XML parse, a DOM document, or a big file get contents, or big array. Okay, and with arrays it's even more complex because you have another variables inside. So you have to keep track in your mind, something like that. How many variables are pointing to my memory so that I can free it as soon as possible. You can see the isRef and the ref count values using Xdebug. Okay, Xdebug, you think you know Xdebug here. Xdebug's got a function which can show you the isRef and the ref count of a variable. So when you smell something strange in your script about variables or memory not being freed and you're expecting it to be freed, just use a quick Xdebug to see, okay, I thought this variable should have been freed, but I see the ref count is 2, so 2 more variables somewhere are pointing to it. If you really want to know who is pointing, what variable is pointing to it, you have to use foreground or GDB down level to see it. Or you have another tools which are very interesting. PHP extension I show you, which is called memtrack, okay, which can show you actually what function is allocating memory and what function frees it actually. So, and you have a very, very nice tool, but it's complicated. It's down level, it's C level. It's called Massive Without Grind, and it's It's very nice. It's the most beautiful tool I've never seen about memory profiling, because it shows you about each C instruction, how your memory is going up and then down and up, and it's something like that. And if you use Eclipse, you have graphical output. So a few more slides just to show you a memory profiler called memprof. This is, you can reach it on GitHub. Okay, so here is an example. This is just an example. So allocating a huge string, allocating an object. Okay, we haven't talked about objects because they are quite complicated to track. Adding the A variable in the object, and a function just loading a file, a PHP file, okay? And we'll see that this is very, very heavy for memory if you have a big script to open. And using memprof, you have something called memprof dump call grind, a function which is added to PHP when you load the extension. And it will put a trace into a file. And this trace, you can open it with kcache grind, like you do for Xdebug. Or you can use the Google Profiler tools as well. It can open it. And you have something like that. Okay, this is size of memory allocated in megabytes. 8 megabytes, 109 megabytes, 2 megabytes for loader, and foo has called string repeat, and string repeat has allocated 8 megabytes. This is what we saw on the last script. So this is a very nice extension, because when you put it on a framework-based application, sometimes you notice things that are not very, very nice, and then you make pull requests on GitHub for those frameworks. And you can see and you can track every function allocating memory and everything allocating memory. You can see that the big array here, the range, is allocating lots of memory, about 100 megabytes of memory, so it's very, very huge. And the loader as well, the loader, so just requiring a file without executing the code in it, it's parsing code, compiling code to bytecode in the engine, and this is takes memory as well. Okay, so sometimes we say, oh, you have a big variable. Oh, from my point of view, I say, oh, you're using a very huge framework and you're just calling 3 functions inside. So you're parsing tons of PHP scripts, compiling them into bytecode and having about 20, 30, or 50 megabytes of just parsing the code, and you call just 1, 2, 3 functions. That's a waste. Okay. So in conclusion, everything consumes memory in PHP. In real-world cases, it's a big DOM document. When you use DOM document, you know that the DOM document actually parses all the XML. Okay, big strings, big file get contents, complex arrays. Arrays are tricky. I get things to say about arrays, things you should know. I will tell you later because I'm out of time now. Heavy results from DBs using MySQL native driver is very, very smart for your memory. When you use libmysql, you get twice more memory fetching a result than with MySQL ND. Okay, we talked about that when 5.3 was released 4 years ago, that MySQL ND has a deep binding into seed values, and it's very, very much more efficient in memory than libmysql. So using MySQL, MySQLi, or PDO, it's any heavy XML. Okay, so you have to benchmark the memory, and I guess you will give a try to this extension. It's a little bit buggy sometimes, little bugs. It's very young extension, but you can pull request Arno about this. And now the PHP ecosystem, APC has nothing to do about memory consumption reduction. It's the opposite. It allocates a shared memory segment, very big. Well, it depends on your apc.ini. So be aware, know how PHP works. Just Google some things or follow internals to see how it works, and don't assume things without proving them. Okay? When I assume, oh, you're gonna have a memory problem over there. I'm just smelling it. No, prove it. Just make a proof of concept, a little script. Use tools, branch them, and show graphs. Give me numbers. Give me graphs to prove what you think. Because sometimes it's the opposite happening. And I guess that's all. Thank you for listening. You can find resources in the wiki, okay, wiki.php.net. You can find resources on my webpage. It's French, but you can translate it easily to English. I'm going to try to translate my articles to English, but it's very hard because it's very long, okay? And you have papers about memory usage in Java and in Python, which are very interesting. How the garbage collector and how the memory allocator in the Java virtual machine works. You can also grab Mozilla documents about Firefox Memory Manager, which are as well very interesting. We get some tricks and port them in PHP when we find full IDs. I guess I have time just for questions. 5 minutes, 10 minutes? 5 minutes for questions.
Hi. The garbage collector, is it called automatically as soon as the ref count goes 0 or afterwards?
It has nothing, well, it's wrong, but it has nothing to do with ref count. PHP frees memory when the ref count reaches 0. No need to garbage collect. Okay, garbage collector has been introduced to solve the circular references problem. You know, an object pointing to another object, things like that. That cannot be freed easily, because if you free B, then A is still pointing to B. If you free A, it's the opposite. So garbage collector is acting just in case of circular references into arrays, or more easily done with objects. Okay? And it consumes memory. 200 kilobytes. Yes? Another question?
Hi. With the references to the variables, if you've got multiple references to kind of the same memory allocation, do you have to unset every variable, or can you actually force all variables to be unset for that memory allocation?
Well, when you use references, I have no time to put all the slides about that, but when you use references, the behavior is changed, and because when you modify a variable, okay, it has to be modified on all the variables pointing to it. If you use references, the unset behavior is the same. Okay, it just decreases the ref count by 1. Okay, but if you have been using a reference, the isRef flag is set to 1, and when it's set to 1. It tells PHP not to free the memory immediately, okay? And it tells PHP other behavior when you pass the variable to functions. So the unset behavior is the same using a reference or not. So if you have A equal foo and B equal &A, so you have a reference. If you unset either B or A, the behavior will be the same. Okay, with unset. The behavior will be changed when you pass your variable to functions or to objects in calls. That won't be the same behavior.
Okay, and can you actually unset A and B at the same time?
Can you?
Sorry, don't worry.
I can't hear because...
He said, can you unset A and B at the same time?
Yes, unset $A, $B. Yeah, sure. No, you can't tell PHP, free this memory now. You can't, because if you are pointing this memory with other variables, when you access them, and then it's accessing freed memory, it's not very good. So no, you can't tell PHP to unset all the variables pointing to the same civil as this variable. It's not possible. No. Any more question, perhaps? No, no more. Okay, so thank you.